Hi, you might be wondering why I've started with this photo. Why Sir talking rubbish? And most importantly, what on earth has this got to do with geology? The answer is that any type of waste disposal is going to have some interaction with the geological environment. And it's that I want to dig into today. Because what today's lesson is about is the geology of landfill. There's no handout that goes with this lesson. You'll need to make your notes as we're going. Okay then. When we throw things away, they don't magically disappear. Most of our solid waste will end up buried in landfill. Incinerating waste generates its own set of problems. Trying to reduce the amount of material that goes to landfill is actually a significant issue that is something the country needs to address. Here in Wales, we are more effective at this than other parts of the UK. But even so, across the UK, there's 110 megatons of waste every year. A couple of hundred kilos per person, although that is reducing as time goes on. But it's still a lot of stuff that we need to put somewhere. Now, when we think about the material that does go into landfill, there are different types. We have inert waste as our first example. Now, inert waste is waste that's unreactive. Some construction material, demolition materials would be classified as inert. Glass, for example, concrete. However, a lot of inert waste actually can be reused or recycled as aggregate. So if a building is being demolished, the inert waste from that demolished building may well be used on the same site, crushed up and used as maybe foundation for roadways or car parks, rather than being transported and dumped in a landfill. Whichever way it's dealt with, inert waste is very straightforward to deal with. You can put it in a hole in the ground and pretty much forget about it. The issue might be that there's actually not a great deal of material that is truly inert waste. Most waste that we need to deal with is what we call putrescible waste. This is waste that will decompose or react. So it could include waste food, green bin waste, but also things like paper and wood. Metals could be part of this as well. It's sort of fairly typical domestic waste. One of the reasons we need to separate waste, particularly things like food waste and garden waste, is because of its potential for decomposition and the problems that that will cause. So these are the two main types of domestic waste that we need to deal with. In particular, I want to focus on putrescible. There is a category as well of special waste. This is stuff that's toxic, stuff that's chemically reactive, stuff that will catch fire. Now this needs this is a whole set of separate issues created by this. This includes radioactive waste that we deal with in another lesson. I'm not really going to focus on special waste in this lesson. So, if we think about what actually goes into landfill, if you think about the contents of your bin that gets collected every week, it may well be a mixture of these things. This is from 2009. So you can see that paper waste makes up a significant amount, as does food and garden waste. All of those are putrescible. We've got plastics making up 10%, glass, metals can be reactive, wood, which is putrescible, as are some textiles. We is electrical waste, and then you've got about 80% of just other stuff. What do you notice about that waste? What do you notice about that split? And if we looked at a more recent graph, how would that be different? What would you expect to see would be different? And would that create issues for putting material into landfill? Okay. If we put rubbish into landfill, it can cause a whole host of different problems. Noise, dust, smells, vermin, whether they're flying or running around on the floor, leachate, subsidence, methane can be an issue, litter, all of these things. Now, I want us to focus particularly on the geological issues. The other problems are important, particularly if you live close to a landfill site. But I think that's perhaps for another subject to deal with. I want to focus on the three things that really are more geological, where there is this interaction with the geological environment. Let's deal with these in turn. This is leachate. Leachate is, well, bin juice, I suppose. It's liquid waste where rainwater percolates down through the landfill site, collecting unpleasant things on the way. Can include heavy metals, can include organic acids, all sorts of horrible things, and wash them out through the landfill. Now, up until sort of the late 1980s, there was landfills were designed to follow a principle that we call dilute and disperse. A better way to put it might be contaminate and pollute, where the landfills were designed to maximise the through flow of water, so that the nasties that were in the waste would somehow be magically washed away, never to be seen again. Now, we know as geologists things don't just disappear in the environment. You know, they'll go somewhere else, perhaps contaminating local groundwater supplies. Since this time, leachate has to be contained within the landfill site and dealt with properly. So, water washing through these types of materials, can cause some real problems, particularly if you have things like maybe batteries thrown into this type of fairly typical domestic waste. We do get, as a result of this, what we call contaminated land. There are a lot of old landfills, ones that were operating prior to the late 1980s, that aren't contained, that aren't sealed. Scarily, any landfills that were operating before about 1974 and are closed by that time, not only do we not know what's in them, we also have no record of even where they are. And it can be a problem then with, when people forget that these things existed, and new buildings, new houses, for example, get built on top of these old contaminated sites. What we'll see under a landfill site then is what we call a plume of leachate. This plume of leachate, its behaviour will depend on obviously the permeability of the rock, any flow of groundwater, because it will go with the groundwater flow, but also the nature of the leachate that's coming out. its density relative to water. So if it's oil, for example, that's leaching out the landfill, that's going to sit on top of the water table. If it's a more dense solution, perhaps of heavy metals and things, that may well sink down through the aquifer and sit at the bottom of the water store. So this stuff will spread away from the landfill site that it comes from, perhaps becoming more dilute, but still potentially causing problems. It is possible to engineer solutions to this. Now, as materials in a landfill site decompose, they're going to reduce in volume. Not only that, over time as well, they're going to get compacted. So anything built on an old landfill site is at risk of subsidence. And remember, very old landfill sites, we don't know where they are. If there isn't a survey done, of actually what's underneath the ground, particularly before a house is built, perhaps it's less of an issue for a major development where more money would be spent on a site investigation. People have come across big surprises with their property. As material decomposes in a landfill, it can produce gas. Principally methane gas if it's organic material, and carbon dioxide gas. Now these gases create different issues and they behave in different ways. Methane is less dense than air, so will rise through the landfill, and then have to be disposed of. Now methane can be burnt off with a flare based at the landfill site. For some larger landfill sites, the methane may be collected and burnt and actually used to generate heat and power. But it's a significant problem. I mean, methane, remember, isn't just flammable, it's also a very potent greenhouse gas. Carbon dioxide, on the other hand, is denser than air. You still don't want it escaping from the landfill, particularly escaping into places that where that CO2 can accumulate because it is an asphyxiant. But because it's denser than air, that will sink down to the bottom of the landfill. Either way, the gas needs to be managed. Now we can see from this map of England and Wales just how many landfill sites there are. These are very common. We tend not to think about them. Our rubbish gets collected by the council and seems to magically disappear. But it has to be taken somewhere, and it's not going to be taken particularly far. So with so many landfill sites, it's really important to engineer them well to be able to minimise or eliminate problems for the local environment. If you look at this is a quarry near Swansea, disused quarry, hole in the ground. It's a potential landfill site. But what might the issues be with using a site like this? I'm thinking geologically in particular. This is it's actually a limestone quarry. What potential problems might there be from using this? What would a geologist need to consider about this potential site? If we think about the properties of limestone, it's going to be very permeable. Any leachate escaping from, or gas escaping from this landfill site here would very quickly disperse from the site. If the leachate was acidic, it will dissolve the limestone. We end up with void spaces which can then lead to instability. So there's a whole host of things that need to be considered. But we do need to put these somewhere. Disused quarries, clay and brick pits can offer an ideal solution. It can also be a way of landscaping the hole in the ground that's been left from extraction. They do, though, need to be close to the people who are generating this rubbish, with good access as well. This particular potential site is in Devon. When a new site is selected now, the first job is to seal the base of the landfill. And this is done with a combination of reworked clay to create a mineral liner, and then this high density plastic sheeting placed over the top, then welded together to create a sealed, if you like, plastic bag in the base of the landfill site, which will keep any materials from the landfill within that landfill site. So you can see there's a lot of work that has to go in before any rubbish can be deposited. And this can't be done retrospectively. Once the landfill is full, the top of the landfill will be sealed in a similar way. And that is for two reasons. Firstly, to stop gas escaping, or to allow for the controlled release of gas rather than the uncontrolled release. And secondly, to stop rainwater getting into the landfill, so minimising the potential leachate hazard. If we look at this is the top of a landfill site. So you've got the waste there, the residuals. Sitting on top of that, then a permeable layer, so the gas can migrate through that very easily. Then you've got the black plastic sheet to act as the impermeable barrier. Drainage material above that. What's that, about 60 centimetres of that, partly to protect the plastic layer as well, to stop it being punctured, and then topsoil and vegetation on top of that to make it look pretty. At the base we see an even thicker layer of this, with built-in drains then to collect any leachate. So we can see that it's really important for a modern landfill site to be engineered to contain the problems within the site, so that any materials that the landfill is going to produce can be contained, can be controlled, and managed. So leachate perhaps might be pumped out and treated before it's disposed of. Gas, carbon dioxide could be vented safely to the air. Methane is probably going to be burned because the carbon dioxide that's made will be less potent than the methane that's produced. Whichever type of domestic waste we're dealing with, these things have to be put in place, almost regardless of the underlying geology. In some cases, though, that underlying geology will require more protection, a real belt and braces approach to containing that waste. Now, we do need to consider some of the issues that surround contaminated land, but that's for another lesson. I'll see you then.